You know the classic butterfly effect, right? I mean, it's probably the undisputed heavyweight champion of pop science concepts. You see it everywhere, movies,
Oh,
books.
absolutely. It's the one everyone knows. A butterfly flaps its wings in Brazil, and, 3 weeks later, you get a tornado in Texas. It's the go-to metaphor for chaos.
And it's a terrifying idea when you really sit with it. It suggests that reality is so sensitive, so incredibly fragile, that a tiny, insignificant movement
Something you can't even see.
exactly can spiral into this massive, unpredictable storm. It makes you feel like you have, well, zero control, like you're just a leaf in the wind.
It really does. It creates this sense of helplessness. It's the ultimate metaphor for how interconnected everything is, but also how unstable. One small nudge, the whole system diverges, and suddenly you're in a completely different timeline.
Exactly. But today,
Yeah.
we're going to completely break that metaphor. Or maybe smash it and rebuild it into something much, much stranger. I want you to imagine that butterfly again. But instead of flapping its wings, or not flapping its wings, imagine it doing both.
At the exact same time.
At the exact same time.
Yeah.
And consequently, the tornado in Texas and the sunny day that would have happened otherwise, they also exist simultaneously.
And that is where our brains usually start to hurt. That is the point where classical logic just sort of throws its hands up and leaves the room.
It really is. This is a deep dive into superposition chaos, and we are looking at a stack of technical reports that are honestly pushing the boundaries of what I thought was possible. We've got the geometry of symmetrical superposition chaos, the quantum geometry of superposition chaos, and some really mind-bending work on parallel determinism.
These are heavy hitters.
Yeah.
And what makes this deep dive so special is that these researchers are attempting a synthesis, a grand unification of sorts. They're taking the unpredictability of chaos theory.
The macro world, weather, turbulence, coffee mixing with milk.
Right, and they're merging it with the all states at once nature of quantum mechanics.
Two things that famously do not get along.
Historically, they hate each other. General relativity and quantum mechanics are like oil and water. But here, they're forcing them into the same room.
And the result is something they call superposition chaos.
It's a fascinating concept. The mission of this deep dive is to explain how scientists are mathematically merging these two incompatible worlds to create what they call a symmetrical stationary state.
Which sounds complicated, but think of it as a map of all potential futures existing at once. So buckle up. We're going to try and give you a visual aha moment about how the universe might actually be balancing luck, chaos, and destiny in a way you've never thought about before.
And to understand this, we have to start by visualizing the impossible. We need to look at the quantum Lorentz.
Right, so let's start with the classical view to set the stage. If you've ever Googled chaos theory, you've seen the Lorentz attractor. It looks like a butterfly. It's this messy looping line tracing a path around two invisible points. It looks like two wings.
Correct. In classical chaos, the world we think we live in, that line represents the history of the system. You, the listener, are a single point traveling along that line. At any given moment, you are either on the left wing or the right wing.
Neither in the storm timeline or the calm timeline. You're having a good day or a bad day.
Precisely. You can't be in both. You're a marble rolling around a bowl. You're here or you're there. Time flows forward, and you trace one single jagged path through history.
But the sources we're looking at today say scratch that. In this new model, we replace that single point, that marble, with something called a density operator or a wave function. Now, for those of us who didn't major in quantum physics, what does that actually look like?
Well, it changes the picture entirely. Instead of a single marble rolling around, imagine a cloud. The technical report describes it beautifully. It says instead of a line, imagine ink, or a cloud of probability that occupies both wings of the butterfly simultaneously.
I love that visual. So instead of me walking down one path, imagine I pour blue ink into this chaos system. It doesn't choose a path. It flows into the left wing and the right wing at the same time.
Exactly. It fills the shape. And this leads us to the concept of parallel determinism.
Parallel determinism. That sounds like an oxymoron. Usually if something is chaotic, it's not determined. It's random.
And that's a crucial distinction to make. Often when people hear quantum chaos, they think it just means extra random, like, oh, now the marble is teleporting randomly. But parallel determinism implies a structure. It's not noise. It's a structured bifurcation.
Okay, so it's organized chaos. The paper on the symmetry of parallel determinism uses a really specific image for this, the diamond of chaos.
Yes, this is a great way to visualize it. It completely reframes how we see cause and effect.
So walk us through the diamond. How does that look compared to the normal messy butterfly?
Well, usually a bifurcation diagram, which maps how a system splits, looks like a tree. It branches out endlessly. One branch becomes two, then four, then eight. It's infinite divergence.
Right, that's the timeline splitting idea where you just end up with infinite universes.
But in a symmetrical rendition, it forms a diamond shape. You have the start, the point of origin. That's the initial event.
The butterfly flapping.
Right. Then the lines diverge. They split apart. But instead of just wandering off into the void, they form a superposition zone in the middle. This is the widest part of the diamond. This is where both paths, future A, the storm, and future B, the calm, exist together.
Okay, so the ink is filling both sides of the diamond. It's getting wider.
But then, and this is the key, they converge. At the end, the diamond closes. The system resolves.
So it's not just a mess of lines running away from each other. It's a closed loop of possibilities.
Precisely. The key insight here is that this framework suggests chaos is a perfectly balanced structure of possibilities. It's not just entropy running wild. It's a container where every chaotic action has a symmetrical counteraction.
That sounds almost philosophical. Like for every action, there is an equal and opposite reaction. But what for destiny?
In a way, yes. But here, it's rigorous math. It's not just a nice sentiment. It's how the equations balance out.
Well, let's get into that math, because it's easy to say everything is balanced, and it sounds nice on a deep dive, but how do you mathematically prove that a hurricane is balanced by a sunny day? That feels like comparing apples and oranges.
It does until you look at the wave function. The source, the quantum geometry of superposition chaos, gives us this equation. Psi of t equals c 1 times wing A plus c 2 times wing B.
Okay, hold on. Let's break that down into plain English.
Yeah.
We have psi as the state of the system, right? The whole thing.
Right. Psi is the whole picture. It's the total reality.
And it's made of two parts.
Wing A and wing B. Wing A represents the trajectory of the storm high energy, high chaos. Wing B is the trajectory of equilibrium, the calm. The equation says the total state of the system is a linear combination of both.
So the universe isn't just calculating the storm, it's calculating the sum of the storm and the calm.
Exactly. You can't have one without the other in this formulation. And this leads to what the report calls the mirror principle.
The mirror principle. I highlighted this section because it made me stop and just stare at the wall for a minute. It felt like one of those moments where you realize the world works differently than you thought.
It has that effect. It completely flips the script on randomness.
The mirror principle states that the energy required to create a chaotic event in future A is exactly offset by a lack of an event in future B.
Yes. Think of it like a bank ledger. The universe maintains a net zero equilibrium. If you withdraw chaos from one side, if you create a massive spike in energy like a storm, you have to deposit calm on the other to balance the books.
So if I'm understanding this right, chaos isn't actually creating disorder, it's just moving it around.
Correct. It's redistributing the geometry of the system. You are borrowing stability from one future to pay for the chaos in another. And this is backed up by something called the Lyapunov exponents.
Ah, the Lyapunov exponents. Every time I read about chaos theory, these come up, and I always struggle to visualize them. They measure the stretching, right?
That's a good way to put it. The Lyapunov exponent, lambda, it measures the rate of divergence. It tells us how fast the butterfly effect happens, how quickly two paths separate.
So a high positive lambda means things are flying apart fast.
Exactly. In classical chaos, you focus on those positive exponents. Things fly apart exponentially fast. That's the scary part of chaos, the unpredictability. The tornado in Texas.
But here is the twist in symmetrical superposition.
Right. The sources point out that for every positive lambda, every stretching or divergence, there is a corresponding negative lambda in the phase space.
A negative lambda would be a squeezing, right? Or a convergence.
Exactly. So imagine you are making a pizza. You have a ball of dough.
Okay, I'm hungry, but go on.
If you stretch that dough out in one direction to make it wider, that's the chaos, the divergence, you have to squeeze it in the other direction to keep the total amount of dough the same.
Because you can't just create more dough out of thin air.
Exactly. The volume has to remain constant. This is called preserving the phase space volume.
So the chaos isn't actually destroying information or creating randomness out of nothing. It's just reshaping the dough.
Precisely. You're stretching the events in one direction but compressing them in another. And to keep this symmetry perfect, the system is governed by what's called a symmetrical Hamiltonian.
Hamiltonian is one of those physics words that sounds intimidating. That's basically the rule book for the energy.
Well,
Right?
the total energy equation. And in this model, the potential energy has to be an even function. In math terms, V of x equals V of negative x.
Which essentially means the mirror image is always just as valid a solution as the original. The reflection is just as real.
That's the philosophical implication, yes.
Uh-huh.
The math doesn't prefer the storm over the calm. They are equal partners in the equation. The universe doesn't want chaos. It wants balance.
That is a wildly different perspective. We always assume the universe tends toward disorder. Entropy, right. Yeah. Things break. Cups shatter. They don't unshatter.
And that's true in our observed reality. But in this superposition state, before observation, the balance is perfect.
Let's move from the math to the texture of this reality. Yeah. Because the sources talk a lot about dimensions, and not just 3D or 4D, but fractal dimensions.
Right. This is where it gets visually stunning. In classical chaos, the attractor is a fractal line. It's rough, it's jagged, it has infinite detail, but it's just a line.
But in superposition chaos,
We move to a fractal manifold. It becomes a complex surface. It's not just a path, it's a whole terrain.
the analogy I loved from the Geometry of Symmetrical Superposition Chaos report was the lace.
Yes, the lace analogy, it's perfect for this.
Paint the picture for us.
Imagine a piece of intricate black lace. Complex patterns, holes, threads. That's your fractal. Now, hold it up to a mirror.
Okay, I'm seeing the lace and its reflection.
The complexity of the lace pattern itself doesn't double. The pattern is the same, but the density of the system increases. You now have the lace and its reflection occupying the same visual field. It looks thicker, richer. The holes in the lace are filled by the reflection of the threads.
And this affects how information is stored in the system, right?
Yeah,
The report talks about the information dimension, G&D.
it does. Think about it this way. In classical chaos, information is asymmetric. It's on one wandering path. If you look at the left wing of the butterfly, the storm wing, you might find all the data there. The right wing is empty.
It's a lonely marble.
Exactly. But in superposition, the information is perfectly distributed. If you were to slice the butterfly down the middle, the information on the left wing is exactly equal to the information on the right.
That's incredible. It implies a perfect redundancy, like a RAID backup for the universe.
It is a perfect redundancy, and it means the von Neumann entropy is at its maximum.
Now, maximum entropy usually sounds bad, like the heat death of the universe.
In thermodynamics, yes. But in information theory and quantum mechanics, maximum entropy in this context creates a pure state of potential. Meaning, the system holds the maximum amount of possibility. It hasn't decided yet. It is everything it could possibly be all at once. It's not messy, it's full.
Until, of course, the fractal bridge collapses.
Right. That's decoherence. When an observation happens, when we check the weather, that beautiful symmetrical fractal bridge collapses back into a single, jagged line of reality.
That's the tragedy of living in the macro world. We can't see the diamond, we only see the jagged line, we only see the storm.
We see the result, not the process, the collapse, not the superposition.
But before that collapse, there's something else happening between the wings. We've talked about the wings themselves, but what about the gap in the middle? The source, tunneling through the wings of superposition chaos, was weirdly poetic about this.
It was, and this addresses a major problem. If you have two distinct states, wing A and wing B, how does the system get from one to the other if there's a gap?
Because in the classical world, that gap is a forbidden region, right?
Yes. Classically, there is an unstable equilibrium in the center. Think of it like the very tip of a sharp mountain peak. You can't balance there. You fall to one side or the other. You're in the valley of wing A or the valley of wing B.
And getting from A to B means climbing all the way back up the peak, which takes too much energy.
Right. So classically, you're stuck in your valley.
But this is quantum mechanics we're mixing in, so we get to cheat.
We get to tunnel. Quantum tunneling is the solution. The butterfly doesn't fly across the gap. It teleports or leaks through it. It goes through the mountain.
The report called it a pressure valve. I thought that was a really helpful way to think about it.
That is a fascinating insight. The expert analysis suggests that tunneling acts as a mechanism to maintain that symmetry we were talking about.
So if the storm wing starts to get too heavy,
Exactly. If the storm wing accumulates too much probability, if the math gets lopsided, particles will hop or tunnel to the calm wing to restore the balance.
so the tunneling isn't just a glitch, it's the system correcting itself.
Exactly. It's maintaining the global symmetry. It's the universe saying, whoa, too much chaos here. Let's move some probability over there. It acts as a regulator.
The visual description here was haunting. It described Faint, ghostly bridges of light connecting the wings, acting as the umbilical cord of superposition.
It creates a connection where there shouldn't be one. It binds the two futures together. They aren't separate worlds. They are communicating vessels.
No, I know what the listener's thinking right now.
Mhm.
Okay, ghostly bridges, parallel determinism, probability dough. This sounds like sci-fi. Or worse, magic.
It does sound abstract. It sounds like something from a comic book.
But one of the sources dropped a bombshell that proves this isn't just theoretical. This isn't just math on a whiteboard.
Hofstadter's butterfly.
Yes, Hofstadter's butterfly. Tell us about that, because this grounds everything we've just talked about.
So, for a long time, since the 70s, this was just a mathematical curiosity proposed by Douglas Hofstadter. But as recently as 2025, we've had solid confirmation. Hofstadter's butterfly is a real fractal pattern that appears in the energy levels of electrons moving in a magnetic field.
So we are talking about real electrons in the real world, not hypothetical particles.
Real electrons. And what they found is that these electrons actually move in these fractal patterns. They trace the shape of the butterfly. And crucially, they tunnel between the fractal branches.
So the butterfly effect isn't just a metaphor for weather. It is a literal physical map of how electrons teleport.
Exactly. The map we are discussing, this symmetrical, tunneling, chaotic map, is literally how the building blocks of matter navigate reality. It's baked into the hardware of the universe.
That is mind-blowing.
Yeah.
So we've gone from a single unpredictable line, the classic butterfly effect where we are helpless victims of chaos, to this symmetrical stationary state where the butterfly is everywhere at once.
It fundamentally changes how you view cause and effect. We tend to think of life as a series of accidents. A random left turn, a missed phone call, a lucky break.
We see the chaos. We feel the stretching of the dough. We feel the uncertainty.
But if we apply this superposition chaos model,
Right.
we see something different. We see the symmetrical ledger.
Right. The math suggests that while we perceive chaos, we experience the storm. The universe is keeping a perfectly symmetrical record of the path not taken. The calm that didn't happen is just as encoded in the wave function as the storm that did.
It connects back to that idea of the superpositioned initial condition the butterfly didn't choose.
Right. The report mentioned this formula. Psi equals alpha times flap plus beta times no flap.
It exists as a probability distribution. It's both. The flap and non-flap are just different facets of the same diamond.
It's a comforting thought, in a strange way. It means the chaos isn't spiraling out of control. It's just one half of a balanced equation.
It removes the randomness. It tells us there is a hidden order beneath the noise.
So, here is the thought I want to leave you with today. We've been talking about electrons and weather patterns and lace. But what if we apply this to you?
This raises a very provocative question.
If the universe really operates on this symmetrical superposition, and we are made of these electrons, tracing these butterflies, then for every chaotic, stressful, stormy moment in your life, is there a calm, balanced version of you existing in the other wing of the attractor?
And are you, in some sense, tunneling through the superposition to balance that equation?
Maybe the calm isn't gone. Maybe it's just on the other side of that ghostly bridge waiting for the waveform to collapse.
It certainly adds a new dimension to the idea of finding your balance. It suggests the balance is always there, even if you can't see it from where you're standing.
It sure does. A massive thank you to our listeners for taking this leap with us. It's a dense topic, but hopefully the world looks a little more symmetrical than it did 20 minutes ago. Thanks for diving deep with us.
Always a pleasure.